Welcome to Leo Academy. Today, we are mastering LeetCode 71, Simplify Path. This is an essential problem for understanding stacks and file system logic. The problem asks us to take a messy Unix-style path and simplify it to its canonical form. Think of it like cleaning up a messy trail of breadcrumbs. We start with a string that has extra slashes, single dots representing the current directory, and double dots for moving up a level. Our goal is to return a clean, direct path that starts with a slash, has no trailing slashes, and removes all unnecessary navigation. Let's look at our strategy. We can split the input string by the slash character. This gives us a list of components. Then, we use a stack to track our directory names. When we see a normal name, we push it onto the stack. If we see a single dot or an empty string from multiple slashes, we just ignore it. But when we see a doubled, it's our signal to move back up, so we pop the last directory off our stack. Finally, we join everything left in the stack with slashes. Let's dive into the dry run. Look at the screen. We have our input path, slash a, slash dot, slash b, slash dot dot, slash dot dot, slash c, slash. First, we split the path. We ignore the empty strings and the single dot. Our first valid component is A. We push it onto the stack. The stack now contains A. Next, we see a single dot. This means stay here, so we do nothing. Then we see B. We push B onto the stack. Our stack is now A then B. Now, we hit a double dot. This is our go back command. We pop B off the stack. We are back at A. We hit another double dot. We pop A off the stack. The stack is now empty, we are back at the root. Finally, we see C. We push C onto the stack. The input ends. We join the stack with a leading slash, and our final result is /C. Now, let's look at the Python code. We start by splitting the path using the slash as a delimiter. We initialize an empty list to serve as our stack. We iterate through each component. If the component is ... we check if the stack is not empty and pop if it is. If the component is not empty and not a single dot, we append it to the stack. Finally, we return a slash joined with the stack elements. Think of it like a GPS history. Every time you enter a new city, you add it to your log. If you hit back, you remove the most recent city. Refresh or staying in the same city doesn't change your log. At the end, your log shows exactly where you are relative to home. Looking at the complexity, the time complexity is O of n, where n is the length of the path, because we process each character once. The space complexity is also O of n, as the stack could store all directory names in the worst case. And that is Simplify Path, mastered. If this helped you, don't forget to like and subscribe for more premium DSA guides.